at least give it a chance.
Which they've not wanted to do so far.
Very few. A few have, and a few have gotten results. I might mention, of course, Professor Ramon Sanchez, who gave it a try, and he got some excellent results. He's another one of those brilliant people I was talking about, creative.
He found out how to extract energy from a distance.
That's right. He actually did the cross beams experiment, and it did work. There are others. I don't mean to say that I've, by any means named all the people. I've just named a few that I've personally worked with. And those people, and many others like them throughout the country, that are doing these unorthodox experiments, and particularly the ones that are doing what we very strongly pointed out here, what John and I have pointed out, are getting results. Now, the problem we all have is that we're still back, figuratively speaking, in this new stuff. We're back very similar stages to where they were in electromagnetics when they were still rubbing glass rods with cat fur trying to work out electromagnetism. The only way we're ever going to get this new science born is for all the sharp young graduate students and all these universities to start doing these kinds of experiments. There's 100 Nobel Prizes out there waiting for you, but it's not waiting for you by simply applying the other stuff that's already been worked out. Go find something new, and here's a whole new area. Have a go at it.
You won't find a Nobel Prize for yourself in your textbooks.
That's correct.
And I'm looking at two men who have put the textbooks aside because they have gone further beyond that. Are you ready to talk to the folks? Tom?
Oh, yes.
All right. Let me give the telephone numbers. If you have questions about free energy or a new kind of energy that you don't have to pay for, let's put it that way. We'll call Bedini and Steve Worth in Dallas, Texas. On our conference line is Tom Bearden. Also in studio with me are some little devices that certainly do not operate in conjunction with the second law of thermodynamics or the law of conservation of energy. They're just destroying those two highly respected principles. But so be it.
But what we have to remember, Bill, is that's how nature works. Nature works this way. Nature doesn't have to pay any attention to any laws at all.
Yeah, they doesn't really care about the laws that man may come up with.
Man, as far as I'm concerned, doesn't have any new laws.
Actually, we touched upon a term a little bit ago, gravity engineering.
Gravitational
engineering.
That's right, Bill. That's exactly what this is. It's gravitational engineering, and this world better get ready for it.
So you're engineering gravity to do work
That's right.
for you.
If our planet spins day in and day out, then there's no reason why we can't tap the spin of the planet, generate all the energy we want, and live like people are supposed to live. We won't have to look at gray skies anymore.
You have a device that turns counterclockwise here in the northern hemisphere, and this produces energy like it was going out of style. Right. If you're in the southern hemisphere, you have to turn it the other way.
I would imagine it would want to go counterclockwise.
And so you're engineering gravity. You're creating electricity for it. Okay, let's go to our callers and see what's on their mind. Who's our first one here, Terry? All right, Craig, you're on.
Am I really? All right.
You're on.
You're actually coming in good and clear tonight.
Craig, you're up at where? Malpetus or up there someplace?
No, in Mid-Pines.
Okay.
Anyways,
I'm glad to have you aboard, and I know it's a strain for you to try to get us up there, but we're glad to have you in.
Well, the reception's good tonight. Let's see. Okay, I'll kind of reverse order my questions.
We have our energy devices working on the transmitter here.
Maybe. John, you were just about to describe the operation of your pendulum device. I am really totally unclear from the previous description as to how it taps into the energy fields. Can you elaborate on that some?
Yes, I can. I have been making chart recordings. You're familiar with that, right?
Specifically, what do you mean?
Chart recordings, like you would chart record earthquakes.
Oh, sure.
Okay. I have been noting that at certain times of the night that the pendulum picks up in momentum. And by that pendulum picking up in momentum, I'm gaining energy without putting any energy into the system.
Okay.
Now, I am describing to you a pendulum, which is a monopole motor in the center.
Before you go further, when you say monopole motor...
One pole, Craig. One pole, a north pole.
That's one thing that didn't make sense.
No complete circuit path, Craig. If you're going to gain any energy, you cannot have a complete circuit path.
Where would a regular person come across a monopole magnet?
Craig?
Yes.
It's the way you place the magnet in the circuit.
Okay, so is it a conventional magnet?
One pole of a magnet. Yes, it is. It's a samarium cobalt magnet.
Okay.
I am only using one pole of the magnet, the north pole.
So it is a dipole magnet, but it's being used
as a monopole.
Okay. Thank you for clarifying that.
Now, I am describing to you, Craig, a monopole motor running a conventional generator. The conventional generator makes up the same magnetic circuits that you are familiar with in the textbook. So what we have here is a monopole motor driving a pendulum effect. Certain times of the night it will pick up because of the Earth's rotation, because it's not what is known as a planetarium pendulum that changes the arc as the Earth spins. You follow me?
Yes.
So what we want to do is pick up the momentum in the middle of the night. We are talking about an item which generates pulse currents. We're not necessarily looking for a constant output, Craig. We're looking for something that goes past the generator poles, produces amperes in a pulse. And that we are sending back to the battery by driving the monopole motor with very little input.
Now, where is the monopole motor in relation to the pendulum?
Right in the center. As the North Pole passes the trigger circuitry that's on this monopole motor, it produces a push which keeps this pendulum rocking no matter what. And then through conventional means, which is in the textbook, we want to gather the energy by the swing of the pendulum. Now, it is also possible to put a Sprague gear or pump water all day long with this pendulum, the same way that an oil well pumps.
You're just extracting the energy in electrical form.
That's right. I am not wasting one bit of energy. I'm returning it back to the system.
So what is essentially the difference you're saying is in the design of the pendulum itself?
Craig, I want you to get, in fact, I want everybody to get a piece of paper and a pencil out there. And I want you to draw a normal pendulum. And underneath that pendulum, right in the center, I want you to put a magnetic coil of some type, and we'll call that the motor. On the opposite ends of the motor, right and left as you face the pendulum, I want you to put two generation coils. I want the monopole to go back and forth between center, right and left, and as it goes between center, right and left, it generates a pulse in current output.